thrust vectoring rocket. So, what is thrust vectoring rocket? Okay. So, why do we require thrust vectoring rocket mechanism? So, suppose just think that this is your rocket, okay, and this is your thrust vectoring mount or your solid rocket motor, okay. So, this solid rocket motor will produce thrust, okay. So, if thrust is produced in this direction, means in suppose this is 0 degree, so it is produced in 0 degree direction, then the rocket will directly go up without changing its trajectory, okay. Suppose if rocket while moving up, rocket angle is being displaced like this, okay, and due to this angle change, rocket will rocket will don't rocket trajectory will be different, okay. Rocket will move like this, but we want that rocket should move like this in state position, so we will vector the thrust. So vectoring the suppose suppose thrust is moving like this, means in this direction. So what we will do, we will change the angle of thrust. So as the angle, just see this simulation, as we are changing the angle, thus rocket is getting straight, rocket is correcting its trajectory, okay. Like this, rocket will correct its trajectory and rocket will go up. We can use this type of mechanism in reusable rockets, okay. Reusable rockets, then now and Chandrayaan 3 has also used this type of mechanism, and we can use this type of mechanism in space only, means it is effective at space, and and with fins also we can vector the thrust. With fins we can control our rocket. But why we are not using fins this time? Because fins will fins will be working in our atmosphere only, means in our Earth atmosphere, because there is aerodynamic forces and all other things. But when we are going to space, there is no atmosphere. So at that time, fins won't work. We can't means we can't control our rocket with the fins. So at that time, we use thrust vectoring mechanism. We will vector the thrust, and through vectoring the thrust, we will get specified specified path that we want. Okay. So we can make the rocket which follows specified trajectory. Suppose this is our rocket, and we want that this rocket should follow this type of trajectory. Okay. So to make rocket follow this trajectory, we will use a thrust vectoring mechanism. Okay. Now, what is the advantage of thrust vectoring mechanism? So the advantage of thrust vectoring mechanism, because as it is having higher level of precision, means yeah, that's it. And now, okay. So when thrust is moving like this, so there will be formation of with using of torque, we will control our rocket. Means suppose our rocket is moving like this. So when thrust will be vectored in opposite direction, that thrust will produce torque in our rocket. That torque will be used to make the rocket in to make rocket in alignment. That's it. Then solid rocket motor. We in this case we are using solid rocket motor. We can use liquid rocket propulsion as well, but liquid rocket propulsion is means for smaller rocket we don't use liquid rocket propulsion, and it will be really costly as well. That's why we don't use that. So if we see, solid rocket motor lasts for only 2 to 3 seconds or 5 seconds, but to make it last longer, we can use some thrust geometries. suppose this is our solid rocket motor, and thrust is coming out from this portion, and when thrust is coming out, this portion will fade away. This whole portion will fade away. This is circular kind of geometry, which is this circular grain geometry. But if you are using star grain geometry, it is like this. So our burn time means our burn time would be 10 seconds or the 15 seconds. 15 seconds. So that's regarding grain geometries. So it's just like gimbal mechanism. Okay. Then comes design. So we will design this in Fusion 360 software, SolidWorks, or anyone. Then we can do some analysis on it. That's it. Then avionics stuff. So for avionics, we are using Arduino, because Arduino is open source software, and we can find libraries of Arduino very easily. That's that thing. Then under avionics, it comes there are some electrical parts that come. Suppose like we have used this Arduino Uno. See this Arduino Uno. Then we have used two servo motor for alignment. Then we have used MPU 6050. It is a gyroscopic sensor which tells us orientation. Okay. So I will tell you the procedure how the things work. See, this is MPU 6050. These are two servo motors. And this is our Arduino board. Okay. So what will happen? I am telling you. And this 6050 will read the data in a X, Y, and Z direction. Okay. Z direction. Then after this X, Y, and Z direction, MPU will read data. Then MPU will transfer the data to Arduino Uno. Okay. Then Arduino Uno. Then these are servo motors. Then Arduino Uno will transfer the data to servo motor. This servo motor, according to the data of X, Y, and Z direction, servo motor, this handle will move. Means it will move like this. According to the angles given by MPU 6050, our servo motors will move. That's it. Then comes the coding part. So coding part is really tough part. Means we use ChatGPT for it. But first we need to check that our servo motor is moving, servo motor is working or not. So to make our servo motor move, we use the code, and for servo motor to integrate it with MPU 6050. Okay, to just check that our servo motors are working or not. Okay, then we included PID controller. PID is most important controller. Without means it take decision on itself. Means if suppose rocket is flying by itself. Okay, but at that time we were not able to control that rocket, because rocket is moving at such a high speed, and it will go for just 5 to 6 seconds or 30 seconds. It will be up. In that time phase, we can't give instruction to rocket. So rocket should take instruction on itself. That's why we use PID controller, so that rocket should take decision on itself. That's it. Now comes manufacturing part. So manufacturing, we haven't done manufacturing till now, but in future we are going to manufacture thrust vectoring rocket. Now it's just a mechanism that I have explained, but we can build a thrust vectoring rocket and we can check it.